Hello, hello students. I hope the voice is clear. Hello everyone. Let me check the voice once. Yes, guys. Yeah. Now let us discuss a few questions from JEE Mains. JEE Mains 27th January morning session from morning session paper. Okay. Yeah. Just I'm checking now. The voice is clear and the clarity of the screen is also okay. If you are not getting clearly, you can just you can change your settings a little bit. Okay. Right. Okay, guys. See, quickly, I will give you the hints and this very simple calculations these questions are involving in. Actually, the analysis part is on 27th January morning session paper is very I can say easy, especially physics is easy, chemistry also easy, maths is little lengthy. That was the feedback we got from students. So let us start with this question from 27th January morning session paper. Right. So the question is, if the diameter of Earth becomes half keeping the mass constant, then find new value of acceleration due to gravity if it's a normal if in normal case it is g. So actually these questions are based on students memory. Okay, students memory based questions, the sentence formations and all. If you see the exact questions in a little bit differently, they may frame the sentences, but meaning of the question should be same. Okay, so what is given here and what you are asked to find? Yeah, see here. One sec. I need to connect with the pen tab. I guess. Right. Okay. See here. Right. Yeah, the question is, if the diameter of earth becomes half. So diameter of earth becomes half means radius of earth also becomes half. Okay. And then what happens to, by keeping the mass constant, then what happens to acceleration due to gravity? So acceleration due to gravity, the relation between acceleration due to gravity and radius and mass is, we know that the relation is small g is equal to gm by r square, capital G m by r square, right? Where g is universal gravitational constant and m is mass and r is radius. By keeping mass constant, if mass is constant, then g into m becomes a constant. So what will you get? G proportional to r square. So based on this, you can calculate the corresponding value. So you can say g dash is equal to, g is of course constant, m remains constant, is equal to r by 2. Okay, as it is a whole square, so r square by 4 comes here, so it becomes, you can write this is equal to 4 times gm by r square. This g dash is equal to, but gm by r square is g, so g dash is equal to 4 times g. That's it. Very simple relation, very simple one. So if you see the options, fourth option is the correct one. It is 4g, right? 4g. That's it. The next question is, yeah, the question is, find the moment of inertia of the system shown in figure about an axis passing through one corner and perpendicular to the plane. Okay, see here, this is it is given that the side length of this shape is a, means it is a square, so all sides are having equal length, right? And we want moment of inertia about any one of the corner. Let us consider this corner. You can mark this as a, B, C, D. So about this corner C, and the axis should be perpendicular to its plane. Perpendicular to its plane means if you consider your paper is the plane, perpendicular to the paper should be the axis when passing through one of the corners. Okay, you have to visualize it properly. Now, so moment of inertia, find moment of inertia. What you are asked to find? Moment of inertia. Moment of inertia of the system is equal to, moment of inertia of the system is I is equal to moment of inertia, because the system is having 4 particles. Particle at A, B, C, D all are having equal masses, and you can say for 4 particles, moment of inertia of the first particle I1 plus moment of inertia of the second particle plus moment of inertia of the third particle plus moment of inertia of the fourth particle, right? So where from the figure, for particle at A, if you take it as 1, so then moment perpendicular distance of the particle from the axis of rotation can be taken as this. What is this? Diagonal. This is A and A. This will be, diagonal should be root 2A. And perpendicular distance of the second particle, which is at point B, is nothing but its a side length. Okay, it is nothing but A. Okay, and perpendicular distance of the particle at D is also A, but perpendicular distance of the particle at C, that is third particle, is because it is axis is passing through that itself, its distance should be 0. So as I is equal to m r square, where r is the perpendicular distance of the particle from the axis, then we can write this as this is equal to I1 at A. For A, I1 is nothing but m into r square. R is root 2a whole square. Root 2a whole square is 2a square. So 2ma square. Then for B, if you take it as I2, it is equal to m into r square. R is nothing but a, so a square. It is equal to ma square. And for particle at C, I3 is m into r square. R is 0, so it is 0. And for particle at D, I4 is equal to again m into perpendicular distance is a only, so ma square. Okay, so if you add all these, you will get the moment of inertia of the system from equation 1. So if you add all this, what will you get? 2ma square plus ma square, right, plus ma square becomes 4ma square. That's it. So from equation 1, and say equation 1 implies I is equal to 4ma square. Any options are given here? Options are not given. So it may be because these are memory based questions. So some what do you call, numerical based questions they might be. Okay, or options the students might have forgot to give. So okay, this kind of question as given, that's what they have informed. So in this kind of questions, you have to remember that if the axis, instead of passing through a corner and perpendicular to the plane, if the axis is passing through any diagonal and lying in the plane, this kind of question also I saw in some other one of the papers from memory based papers, that kind of question is given like that they have mentioned. That means maybe students might have confused whether this or that. If that is the case, you have to consider perpendicular distance of the particle from the axis. Okay, so we have to be careful while taking this perpendicular distances, right? So in this particular case, this is the answer, right? Next question quickly. Two particles having masses 4g and 25g, means grams, masses, okay, 4 gram and 25 gram, actually you have to mark like this, 4 gram and 25 gram have same kinetic energy. Find the ratio of their momenta. Find the ratio of their momentum. We cannot use the word momentums or momenta. Plural of momentum is momenta. Okay, right. As there are two particles. They are having masses, different masses, and they are having same kinetic energy. So the condition here is kinetic energy of the first particle is equal to kinetic energy of the second particle, right? And if by knowing the masses, how to find the ratio of their momentums or momenta? So you need to think about the relation between kinetic energy and momentum. So we know that here you can write, because kinetic energy in terms of momentum is nothing but k is equal to p square by 2m. You should remember this, p square by 2m. Okay, from this relation you can say, as you want a ratio of momentum by giving kinetic energies are equal, so momentum of the first particle can be taken as p1, so p1 square by 2m1 should be equal to, for the second particle it is given as p2 square by 2m2, right? So here 2 gets cancelled, so we can write p1 square by m1 equal to p2 square by m2. But we want the ratio of momentas, linear momentas. So let us bring a p2 square here to the left side, and we can write p1 square by p2 square, or p1 by p2 whole square is equal to m1 by m2. m1 by m2. p1 by p2 equal to square root of m1 by m2, right? So p1 by p2 is equal to square root of m1 by m2, where m1 is given as in the question. m1 is 4 gram, m2 is 25 gram. So it is equal to square root of 4 by 25. Gram gets cancelled. Root 4 is 2, root 25 is 5, 2 by 5. So if you see the options, what is the answer, you can understand. So what is the ratio of P1 and P2? 2 is to 5 or 2 by 5. See the options here, 2 by 5 is the first option. First option is the correct one. That's it. Okay. Next question. So this is the answer. I hope it is clear for you all. Right. Next one is, this is the end of the answer for this question. Next question. Yeah, this is the question. An object of mass 1000 kg, an object of mass 1000 kg is moving with a speed of 6 meter per second. Find the speed of, find what? The speed of the object if mass of 200 gram is added to it. If mass of 200 gram is added to it. So how to do it? Here you have to understand that, let us say there is a big mass of 1000 kg. You can say there is a trolley or big trolley or a block or whatever it is. This is a mass capital M, which is equal to 1000 kg. 1000 kg. Initially it is moving with the velocity v1, which is equal to 6 meters per second. Now if you add a small m to it, small m to it, so the total mass becomes capital M plus small m. Capital M plus small m. The small m is how much? It's 200 kg. So it becomes 1200 kg. This is 1000 kg initially. Now 1200 kg. It is moving with what velocity now is the question. V2 is what? So what you have to understand is, when you are adding mass, no external force is acting on this system. So when no external force is acting on it, we can say the linear momentum of the system should be constant. So that means before adding the mass, momentum from, we can say, from law of conservation of momentum, from law of conservation of momentum, from law of conservation of momentum, conservation of momentum, when no external force acting on the system, total initial momentum is equal to total final momentum. So total initial momentum is initial mass capital M into initial velocity v1 is equal to final mass capital M plus small m into final velocity, you can take v2. What is this v2 is the question. Okay. So here initial mass is 1000 into initial velocity is 6 is equal to final mass is 1200 into final velocity we don't know. So 2 zeros, it's cancel, right? And 6 ones, 6 twos, 2 ones, 2 fives. So v2 is equal to 5 meter per second. Obviously when the mass is added, it will try to move slowly, so the speed becomes slow, right? So this is how you can work out these kind of questions. I hope it is clear for you. This is the end of the solution. This is the final answer for this question. I hope it is clear for you all. Next, let us see the next question. Right. See here guys. In this question, so these are all belongs to JEE, IIT JEE Mains 2024 January 27th morning session questions guys. Okay. Right. So this question is, a particle performs SHM, simple harmonic motion with an amplitude of 4 cm. What is given here? Amplitude. So you can write down the given data also. Okay, amplitude is given as A is equal to 4 centimeter, and speed of the particle at mean position is what is this, 100 or 10 centimeter per second, I think. Yeah, it is 10 centimeter per second. Speed V is equal to 10 centimeter per second. Find the position from the mean position where speed is 5 centimeter per second. Find the position from mean position. Let us say if this is a to and fro motion and this is mean position. Mean position means x equal to 0, and this is extreme position, x is equal to plus a, and this is x is equal to minus a. Right, at mean position speed is we will be maximum at mean position, it is equal to 10 centimeter per second. Obviously at extreme positions it stops momentarily and the motion will repeat itself. Okay, so now in this process, so as V maximum is given here, you also have to remember that V maximum value of speed in SHM is nothing but omega A. It is 10 centimeter per second, but amplitude is given here. By using this we can calculate omega. This implies omega is equal to 10 centimeter per second by A is 4 centimeter, right? This centimeter gets cancelled per second, so it is 10 by 4 or 5 by 2, 5 by 2 or 2.5, depending on the requirement. You can use any of these as it is. Okay, per second is nothing but actually radians per second. So but here we have to just take in terms of the given units, right? This is omega. Next you are asked to find what is the position. The question is, what is the position from the main position where velocity becomes 5 centimeter per second is the question. So what you have to think is, you should recollect back the relation between velocity in SHM and position. Okay, velocity, the relation between velocity and position is nothing but V is equal to omega into square root of a square minus x square. You have to remember this. From this you have to say, as V is 5 centimeter per second, it is equal to omega is 5 by 2. You can take 5 by 2 into square root of a square minus x square. A should be 4 centimeter square, so 4 square is 16 minus x square. So 5 cancel, it is 2 equal to this, and if you square on both sides it becomes 4 is equal to 16 minus x square, right? And if you simplify this further, so what you will get? So you will get the required answer. So what should be that? Check it out. Can you just the calculations are okay? Is it is 4 only, right? So it is x square. If you bring x minus x square to left hand side, it becomes plus x square is equal to 16 minus 4 is 12. So x is root 12. X is root 12 centimeter. If you see the options, what are given here? 2 centimeters, 2 root 3.5, root 3 centimeters. So root 12 is not there. They have simplified form is there. So how can you simplify this further? You have to think about. You can write it this 12 as 4 into 3. So 4, this is equal to under root 4 into 3. So 4, if you bring out, it becomes 2. So you can further you can write it as 2 root 3 centimeter will be the x value. So which option is right? 2 root 3. Second option is right. So this is how you have to work out this kind of questions, guys. Yeah. So these are few questions from January 27th morning session of IIT JEE mains. Okay, few more questions we will discuss. Okay, in the next session, maybe tomorrow. Till then, take care. Bye bye. I hope the answer is clear for you. Everything is clear, step by step it is clear. If anything, if you need, you can drop me a message. Okay guys, take care. Bye bye.